We are going to be solving a more complex trig equation. The complexity lies in the fact that we're solving for x, and the equation that we are given is that the tangent of 3x equals -1. Our first step would have to be to find the reference angle for 3x, and then only after we have solved for the angle 3x will we then go and solve for the angle x. It is complicated further by that the interval that x can lie in is between 0 and 2 pi. So we are solving for x and not 3x. That is why we need to get the general solutions for x and then finally see which values of x are lying in the interval between 0 and 2 pi. So the first step would be to find the reference angle for 3x. Tangent is y over x. So the reference angle is an angle in the first quadrant and an acute angle. So again, I have a look and say which y over which x would give me 1 as an answer. Starting with an angle of 0 radians, y over x is 0. Pi over 6, y over x is 1 over root 3. For an angle of pi over 4, y over x root 2 over 2 divided by root 2 over 2 is 1, making pi over 4 the reference angle. So now we know our reference angle is pi over 4. Our next question is, in which quadrants could 3x lie? Because tangent is periodic every pi radians, if my answer, as it is in this case, is in quadrant 2 and 4, we do not have to solve for both quadrant 2 and quadrant 4, because if we just add pi to quadrant 2, we land up in quadrant 4. Making it simpler in that I need to only handle angle 3x lying in quadrant 2 and then add pi to get into quadrant 4. I have the reference angle is pi over 4. I have written it in here. To get into the second quadrant, we need to say pi minus the reference angle. So my angle 3x, which is lying in both the second or the fourth quadrant, could be pi minus the reference angle of pi over 4 and then plus k pi, because we could move from the second to the fourth, adding pi radians. Adding another pi to the fourth quadrant would bring us back to the second quadrant. Adding pi to the second quadrant brings us back to the fourth. Or subtracting pi from the second quadrant would bring you back into the fourth quadrant. Subtracting pi from the fourth quadrant would bring you back to the second quadrant. So this here is the general solution for angle 3x. We have 3x equals pi minus the reference angle because we're in quadrant 2. Adding k pi would bring us to quadrant 4, back to quadrant 2, where k is an element of integers. We are asked, however, to solve for x, not for 3x. So I go and divide each term by 3. 3x divided by 3 is x. Pi divided by 3. Pi over 4 divided by 3 would give us pi over 12. K pi divided by 3 is k pi divided by 3, and our k is still an integer. Well, putting everything over an LCM of 12, we get that x, which we are trying to find, is equal to 4 pi minus pi plus 4k pi. By bringing these three terms over the LCD of 12. Adding 4x minus 4 pi minus pi, we get 3 pi plus 4k pi over 12, where k is an element of integers. I now want to see which values of k do I put in there to give me values of x which are in the interval between 0 and 2 pi. 0 and 2 pi is the interval that we are solving on. So, when k is negative 1, you would see that you get 3 pi minus 4 pi, which is a negative angle which is not in this interval given between 0 and 2 pi. So, when k is 0, you would have 3 pi over 12, the first angle listed. When k is 1, we would have 3 pi plus 4 pi over 12, 7 pi over 12. When k is 2, we would have 3 pi plus 8 pi over 12, 11 pi over 12. When k is 3, we're going to have 12 pi plus 3 pi, 15 pi over 12. When k is 4, we're going to have 3 pi plus 16 pi over 12, 19 pi over 12. And when k is 5, we will have 3 pi plus 20 pi, giving us 23 pi over 12. When k is 6, we will have 27 pi over 12. 27 pi over 12 is out of this interval because our interval can only be between 0 and 2 pi. So 27 pi over 12 is too big. So these are the possible values of x, which if you had to replace any value of x into this equation over here, tangent 3x equals negative 1, replacing any one of those values into that equation, your answer would be negative 1. Any one of those x values makes that a true statement. So those are all of the solutions. Well, we can simplify these numbers a bit further, and 3 pi over 12 simplifies to be pi over 4. 15 pi over 12 simplifies to be 5 pi over 4. And the other values remain the same. So these are the solutions of this red equation, tan 3x equals negative 1, over the interval from 0 to 2 pi. Up until now, when we've had a look at the interval 0 to 2 pi, we've only found two solutions. But because we are given that the tangent 3x equals negative 1 and we are solving for x, we now have 6 possible solutions for x that would make this equation true.